I did problem number 15, which says, if the number of 93 factorial ends with k zeros when given to the base 12, and ends with h zeros when given to the base 10, find k plus h. So we've done this problem before in base 10. So that's what I'm going to start with, and then I'm going to explain why we're doing it. So when we've done this problem before, we had to figure out how many 10s go into 93 factorial, and that gives us the number of zeros at the end. So to find the number of 10s that go into it, we need to find the number of 2s and 5s that go into that number, because 2 times 5 is 10. So to find the number of 2s, we have to divide it by 2, and that gives us 46 with a remainder, but we don't care about the remainder, so I'm just not going to put it. And then we need to divide it by 4, because that gives us an extra 2, because 4 is 2 times 2, and that's 23, and we don't care about the remainder. And then divide it by 8, 11, and then divide it by 16, which is 5. So the number of 2's in 93 factorial is 46 plus 23 plus 11 plus 5 plus 2 plus 1, which is 88. Now we have to find the number of 5's. So divide it by 5, and that gives you 18 with a remainder that we don't care about. And then divide it by 25, because that gives us an extra 5, and that's 3. And then the next one would be 125, but that doesn't go into 93. So the number of 5's in 93 factorial is 21. So we can only go up to 21 10s. There are 21 10s in 93 factorial. So and that implies that h equals 21. So now we have to find k. So k, we're dealing with base 12. So we have to understand why we're finding the number of 10s that go into this number. And you might be thinking, well, it's because if a number is divisible by 10, there's a 0 at the end. But we have to understand why there's a 0 at the end. So to understand that, we have to understand what base 10 really means. So for base 10, you have something times 10 to the 0 plus something times 10 to the first plus something times 10 squared, and so on. So if there are 2 10s in that number, then, so like, say 100. 10 goes into this twice, so that's why there's 2 zeros, because this is 0 times 10 to the 0 plus 0 times 10 to the first plus 1 times 10 squared. So 10 goes into this twice, that's why there's 2 zeros, one here and one here, and there's 1 there. So in base 12, you have something times 12 to the 0 plus something times 12 to the first plus something times 12 to the squared, and so on. So if you have a number like 36, This is, well, actually let's not do, oh yeah, 36. 12 goes into 36 one time. So this is 0 times 12 to the 0 plus 3 times 12 to the first. So 36 in base 12 actually equals 30. So that's 0 times 12 to the 0 plus 3 times 12 to the first. So the number of zeros at the end of a number in base 12 is dependent upon how many 12s go into that number, not how many 10s go into that number. So back to this problem, we have to figure out how many 12s go into 93 factorial. And you know 12 breaks down into 4 and 3, 2 and 2. So 12 equals 2 squared times 3. So we're going to have to look at how many 2's and 3's are in the prime factorization. So we already found the number of 2's, that's 88. So now we have to find the number of 3's. So divided by 3, that's 31. And then divided by 9, because that gives us an extra 3. That's 10, with a remainder that we don't care about. And then 93 divided by 27 is 3. 93 divided by 81 is 1. So the number of 3's in 93 factorial is 31 plus 10 plus 3 plus 1, which is 45. So we have to look at the number of 2 squared. So it's going to be 93 factorial equals 2 to the 88 times 3 to the 45 times whatever else. But we have to look at 2 squared. So this is, if you rewrite this, it's 2 squared to the 44 times 3 to the 45. So that means that there are 44 12s that go into this number. So there's 44 12s in 93 factorial, which implies k equals 44. So what you're trying to find is k plus h. So k plus h equals 44 plus 21, which equals 65. And that's your answer. Thank you.